All right, on to section 2.2. We move. Section 2.2 was the normal distribution and density curve. So let's start there. Density curve is just a curve that we're going to draw over the data from a histogram, dot plot, stem plot, any one of those, so that we can find the area under the curve. So there was two properties that we talked about when it came to density curves. The first was that it's always on or above the horizontal axis because the probability has to be 0 or positive. And then the area under the curve is 1 because the sum of all the probabilities is 100% or 1. So we talked about mean versus median. This is just if the distribution skewed right, the mean is greater. Skewed left, the mean is less than the median. You could think of the mean as the balancing point and the median as the equal areas point. All right. Then we jumped into the 68, 95, 99.7 rule. And what that says is this. If a distribution is approximately normal, then about 68% of the data is within one standard deviation of the mean, 95% within 2, and 99.7% within 3. So then we moved on to the standard normal curve, and that's where we standardize things. So let me just give you some information here. Say we have a test, and the average for the class is 84, and the standard deviation is 6. The mean is a measure of center. The standard deviation is a measure of variability. So if I subtract the mean and divide by the standard deviation, a shift affects measures of center. So the new center would be 84 minus 84. And rescale affects measures of center. So this new center would be 0. For the variability, 6. Adding and subtracting does not affect the variability. So I'm not going to subtract the mean. Dividing, the rescale does affect it. So I end up with 1. So the standard normal distribution has a mean of 0 and a standard deviation of 1. So that's what we talked about there. This comes up a lot when we do normal CDF in the calculator. Those last two numbers are always 0 and 1 because we're using the standard normal curve. All right. Then what we jumped into is finding area under the curve. And we did this using normal CDF. And then we did vice versa where you have to use inverse norm. So you'll notice just a couple examples here. Normal CDF, lower bound, upper bound. We always use that mean and standard deviation of 0 and 1. Inverse norm, you put in the percentile or the area to the left, the middle, or the right, depending on your operating system. And that's going to give you a z-score. And then when we actually get to z-score questions, there's 3 steps that I'm looking for and the AP is looking for. That you draw, label, and shade your distribution. That you show your work for your z-score calculation. And then you answer the question in context. So I've said this before, it's worth repeating again. If you're only using the shortcut on the calculator and you're not using the standard normal curve, you will not get full credit. That's why I'm harping on that so much. They call it calculator speak. It's not considered clear communication. So let me go through one of these examples so you can have a sense of what's happening here. So in this question here, the distribution of blood cholesterol level is approximately normal. Here's the mean, here's the standard deviation. What's the first quartile? So basically, I'm drawing, labeling, and shading. Here, I'm given the area under the curve is 0.25 because it's the first quartile. So I'm doing inverse norm of 0.25, inverse norm of 0.25. That gives me a z-score of negative 0.67. So now it's the value minus the 170 divided by the 30. Do a little math there to end up with 149.9. So that would be using inverse norm. The other examples, if I need area under the curve, let's just look at something very simplistic. Tiger Woods hits the ball. His ball travels, follow a normal distribution with a mean standard deviation. What percent of his drives travel at least 290 yards? Draw, label, shade the distribution. Now we know the mean, we know the value. So value minus mean divided by standard deviation, negative 1.75. And then I'd use normal CDF here. I'm not sure if they wrote it in here. No. Yeah, okay. So again, this is the shortcut. We should not be using this. The lower value would be negative 1.75. The upper value would be a very large number, infinity, 999, whatever. Mean 0, standard deviation 1. And that's going to give me the area under the curve. So I think that's pretty much it. Assessing normality, this is just going through to see, is the data that you have approximately normal? So if you have a set of data, plug it in, list one, calculate the summary statistics, figure out the mean and standard deviation, and figure out what percent of the data is within 1 standard deviation, 2, and 3. You could see they did that over here on this example. So this follows the 68, 95, 99.7 rule pretty close. So between the graph, which looks like a normal curve, would be a pretty good fit, and checking the 68, 95, 99.7 rule, it seems like, yes, a normal distribution would be a good fit here. Normal probability plot is not part of the AP curriculum, so you don't need to worry about any of that. So that's it for Chapter 2, and that is the end of Unit 1. Unit 1 covers all of Chapter 1 and all of Chapter 2 as far as the AP College Board is concerned. So hopefully that was helpful.